are phytoplankton? Phytoplankton, also known as microalgae, is like terrestrial plants in that they rely on chlorophyll and sunlight to live and grow. They also need inorganic nutrients that they convert into fats, carbohydrates, and proteins. The two major classes of phytoplankton are dinoflagellates and diatoms. Dinoflagellates are covered with complex shells. They use a whip-like tail to get around in the water. Diatoms have shells too, but are composed of a differing body. The structure is rigid, and they rely on ocean current to get around the water, as they do not have the whip-like tail dinoflagellates have. Phytoplankton may grow out of control if surrounded by excessive nutrients, and as a result form algae bloom, which produces very toxic compounds that will impact harmfully on fish, mammals, birds, and humans. These single-celled organisms inhabit 3/4 of the world's oceans. This is the average sea surface chlorophyll from 1998 to 2006. Over time, plants play a major role in pulling CO2 out of the atmosphere. This has been the case for the past 3 billion years when photosynthesis evolved into cyanobacteria, the most abundant type of phytoplankton. Sunlight is used by phytoplankton as energy to split water molecules into hydrogen and oxygen atoms. Oxygen is released as a product to be consumed by life on Earth, while hydrogen is used to help convert the inorganic carbon in carbon dioxide into organic matter like amino acids, sugar, and other biological molecules that constituent their cells. Now, how has increased atmospheric carbon dioxide acidifying the ocean? Well, since the beginning of the Industrial Revolution, the ocean has absorbed 1/3 of the fossil fuels emitted into the atmosphere. This is positive as it slows climate change. But the vast amount of CO2 in our oceans is altering the sea chemistry. Often carbon dioxide dissolves in the sea. Carbonic acid is formed, which decreases pH near the surface and increases acidity. Phytoplankton consume the greenhouse gas CO2 out of the atmosphere and accumulate it deep in the ocean. This is part of the carbon cycle, which can considerably influence the global climate. The decrease in pH and increase in acidity creates difficulty for marine life and threatens the number of organisms. This can be corrosive to those with calcium carbonate shells, corals, and the shells of tiny snails that form a key link in the marine food chain. Now, how does acidifying the ocean impact on the ability of plankton to regulate climate? The global warming that accompanies ocean acidification increases the temperature of the upper ocean. This reduces the abundance of nutrients and thereby linked to a decrease in the biomass and productivity of phytoplankton globally. Also, phytoplankton can't absorb the increasing amount of fossil fuels, which brings buried carbon back into circulation. They can't absorb the carbon dioxide fast enough to keep up with the increasing concentrations of the greenhouse gas in the atmosphere. Hello and welcome everyone. Please help me welcome Dr. Jennifer Alcalis, who is from the Scientific American and works as a marine biologist. How are you, Doctor? Thank you. So, Doctor, according to your research, can marine plankton play a role in regulating the Earth's climate?
First of all, I'd like to thank you for giving me the honour of being your guest tonight. Now, the ocean is too big to obtain constructive, reliable, representative data, and satellites can be used as a better source of global coverage than any combination of field experiments. However, they are somewhat limited to graphical signatures. But speaking on a lower level, the experiments conducted by scientists account for some evidence that prove the importance of phytoplankton's key role in the ecology of marine ecosystems and carbon cycle. Some scientists that I work with in the lab have suggested to fertilize the ocean with dilute iron solution to artificially enhance phytoplankton photosynthesis and the biological bump. However, I think that an overproduction of phytoplankton can produce marine biotoxins. Also, these overblooms are consumed by fish and shellfish. so the biotoxins will accumulate and in turn render the fish and shellfish extremely toxic to whoever consumes them, like marine life, seabirds, and even possibly us, humans. So furthermore, these blooms will cover the top layer of the ocean, thus preventing essential sunlight entering through to the seabed to be consumed by the marine life. And as sunlight is, essential. So yeah, that's. I would like to add that phytoplanktons may be of great assistance to regulating the carbon cycle. However, their assistance will gradually diminish, in my opinion, as the global human population increases and the greenhouse emissions increase to endure with the world's activity for production and profit. And I also want you to look at the following graph, which illustrates the rise in the atmospheric carbon dioxide from 1744 to 2005. Also, note that the increase in carbon dioxide's concentration in the atmosphere has been exponential during the period examined, and extrapolation in the immediate future suggests continued increase. So that's just my opinion about the matter. Thank you for having me here today, and I hope everyone has learned something. Thank you.